Welcome to today's lesson. In this first tutorial, we will solve quadratic equations by factoring. So we are still with our factoring, and we will continue to factor our trinomials by the grouping method in this tutorial. But today we're going to be solving equations. Remember the difference between an expression and an equation. An expression does not have an equal sign. An equation does have an equal sign, and if there's an equal sign, then we will be solving our equation. So today we have all equations. We're going to be looking for their roots, or in other words, their zeros, or their x-intercepts, or their solutions. Remember that all four of these words mean exactly the same thing. We're ultimately looking for the answers to our equation. We will be solving these equations using the zero product property. The zero product property says that if I have two or more factors all multiplied together that equal to 0, then each one of them could be equal to 0. So A could be equal to 0, or B could be equal to 0, or C could be equal to 0, or all of them. If you have numbers multiplied together that give 0, then one of them has to be 0. So we need our equations to be equal to 0, and then we need to factor the left side, and then set each factor equal to 0 to find our answers. So that's it. Let's look at example 1. Example 1 is the easiest type of equation that I can give you to solve. It's already set equal to 0, and I've already factored the left side for you. So since the zero product property says that each factor can be set equal to 0, I simply need to put x plus 2 equal to 0 and 3x minus 1 equal to 0. I have two little equations to solve, and I will have my answers. So to solve this equation, of course, I'm subtracting 2, and I get that x equals negative 2. That's one of my roots. And to solve this equation, I need to add 1 and then divide by 3. So I'm going to have that x equals positive 1 because I added 1, and divided by 3 because I divided by 3. So x equals 1/3 is my other root. Let's look at example 2. Now example 2, I don't see a 0 yet. Some of you might say, well, wait a minute, I see x squared minus 36, and that's a difference of two perfect squares. And you'd be correct, but factoring this would not help us because we do not see a 0 yet. The first step today is to make sure our equation is equal to 0. So I need to subtract 5x. And when I subtract 5x and bring it over to here, I want to make sure my terms are all in the correct order. The first term should always be your quadratic term. That's the x squared term. Then, since I'm subtracting 5x, it'll be a negative 5x. The x term comes next. And the negative 36 will just slide on over and be last. That's my c term. All equal to 0 because that's what I need to see. I need my 0. Now I have a trinomial, and I'm going to factor this trinomial using the grouping method. I'm taking my first coefficient, which is 1, and my last coefficient, which is negative 36. I'm multiplying them together. I'll come over here. 1 times negative 36 is negative 36, and now I need to find the pairs of numbers that multiply to give negative 36. So negative 1 times 36, and negative 2 times 18, and negative 3 times 12, and negative 4 times 9. Negative 5 does not go into negative 36, but negative 6 does. It goes 6 times. So I actually have 5 pairs of numbers that multiply to give negative 36. I'm looking for the one pair of numbers that will add to give negative 5. So let me look through here, and oh, I see the negative 4 and the 9. Negative 4 and 9 make positive 5, and I need a negative 5. So I'm going to change this to a positive 4 and a negative 9. That will add up to negative 5, and it will still, of course, multiply to negative 36. So that's the pair of numbers that I need. I'm going to take my negative 5x and change it to 4x minus 9x. And now I can see 1, 2, 3, 4 terms. Let's rewrite those terms. I've got my first term as x squared. My middle two terms will be positive 4x and negative 9x. And my last term is negative 36. All equal to 0. Don't forget that you have an equation. Now I've got my 4 terms I'm going to be factoring by grouping. I'm going to group my first two terms together and pull out the GCF. I see a common factor of x, and what's left when I divide the x out is x plus 4. I'll group my second two terms together. My last two terms, I should say. And since the last two terms start with a negative, I'm going to be factoring out a negative. 9 and 36 share a 9, so I'm going to factor out a negative 9. Watch out when you're factoring out a negative because things change signs. Negative 9x divided by negative 9 is positive x. Negative 36 divided by negative 9 is positive 4. And we still have an equation. I stop here to make sure that I've done things correctly. If I have, my parentheses should be the same, and they are. And since they're the same, they are common. So I can factor out this common factor of x plus 4. When I do that, I'll be left with this part x, and this part negative 9 in the other factor. It's still equal to 0. Now that I have my 0 and I have my product, I can use the zero product property. X plus 4 can be equal to 0. That will give me that x equals negative 4. X minus 9 can be equal to 0. When I add 9, I'll get x equals 9. And those are my two roots. All right. Let's try a third one. 12x squared minus 8x equals 15. Well, this has the same situation as problem number 2. I do not see my 0 yet, so I'm going to need to subtract 15. I'll bring that on over here. But let's make sure that our terms are in the correct order. 12x squared should come first, the negative 8x should come second, and since I subtract 15, I will have negative 15 come last. That is equal to 0, and that's what I need to see for my zero product property. Once I have my 0, now I need to see my product. And to find a product, I need to factor. So I'm going to factor this trinomial. I'm going to do this by grouping. I'm going to take the first coefficient and the last coefficient. I'm going to multiply them together. And 12 times negative 15 is negative 180. Wow. Negative 180 has a lot of pairs of numbers that multiply. So instead of sitting here and listing all of those pairs, let me show you a different technique on the calculator. So grab your calculator. If you ever have a number that's going to have a lot of factors, or if you're having trouble finding the factors of even smaller numbers, you can use this trick. Let's turn our calculators on and go to y equals. I'm going to be plugging in a fraction, so I'm going to use my fraction button. That is alpha, y equals, enter. So there's my fraction. I'm going to put the negative 180 in the numerator, and I'm going to put an x down in the denominator. So I type that into y1, negative 180 divided by x. I would like to look at the table of values. The table is up here in blue, so I need to push the blue button. Second, table. And this is all of the table of values. I get an error when x is 0 because I can never divide by 0. But after that, we get 1 times negative 180, 2 times negative 90, 3 times negative 60. The first number that does not go in evenly is 7 because I see a fraction after that. And 8 doesn't go in evenly either. But all the numbers that are not fractions will be factors. Now remember what we're trying to do. We're trying to find the factors of negative 180. I already found those in the table. But the ones that add up to negative 8 are the ones that I'm interested in. So let's see. If I used 3 and negative 60, well, that would add up to negative 57, so that's no good. And 5 and negative 36 add up to negative 31, so that's no good. Let's keep going down this list until we find a pair of numbers that add up to negative 8. Let's see. 9 times negative 20, but that would add up to negative 11. I'm getting closer. 10 and negative 18. 10 and negative 18 add up to negative 8, so that's the pair that I'm interested in. So I've got 10 times negative 18. That multiplies to negative 80 and adds to negative 8. So that's the pair that I need. I'm going to take negative 8x and rewrite it as 10x minus 18x. So feel free to use the calculator to help you find the factors that will work. Let's rewrite all four terms now. I have 12x squared plus 10x minus 18x minus 15 all equal to 0. Now I can do my grouping. I'm going to group the first two terms together and pull out a common factor. I see that they're both even, so I can pull out a 2, and they both have an x, so I'll pull out a 2x. If I divide a 2x out from 12x squared, I will have 6x, a plus sign, and 10x divided by 2x will be a 5. Let's see, my next grouping, the last two terms, it starts with a negative, so I will be pulling out a negative. 18 and 15 share a 3, so I will be pulling out a negative 3. They don't share a variable, so it's just this number. Let's see what happens when I divide by negative 3. If you want to divide by negative 3 and actually show that, that's absolutely fine. It goes right here. Negative 18x divided by negative 3 is positive 6x. Negative 15 divided by negative 3 is positive 5. We still have an equation, so please do not forget that. I stop here to make sure that I've done things correctly, which I have. I have my same parentheses, so I'm going to pull out the 6x plus 5, factor it out, 6x plus 5, and the parenthesis that will have the remaining things will have a 2x and a negative 3. So 2x minus 3. We're still dealing with an equation. Let's not forget that. We have our 0, we have our product, so now we can use our 0 product property. I'm going to set 6x plus 5 equal to 0, and 2x minus 3 equal to 0. When I solve these two equations, I'm going to be subtracting 5, so a negative 5, and then dividing by 6, so negative 5/6. When I solve this equation, I'm going to be adding 3, so a positive 3, and dividing by 2, so 3 divided by 2. And I've got those two answers, and I've solved it. So there are 3 examples of factoring by grouping and solving the equation using the 0 product property. Thanks for watching this tutorial. I'll see you in the next tutorial and in class so we can practice this some more. See ya.